we are discussing the second part of Java programming structure. In the part 1, what we have discussed is, we have discussed about comments, types of comments in Java, then followed by package declaration and import statement, package importance, how to declare package to class, how to import the package and class to other packages, and also we have discussed about all the access specifiers in the class, like private, default, protected, public access specifiers. So that is how the first part is completed. Coming to the second part. In the second part, we are going to discuss about the class, variable, constructor and method. Declaration of class, variable, constructor and method. Their syntaxes and how to declare class, how to declare variable, how to declare constructor, how to declare method. Which access specifier we can apply on class, which modifier we can apply on class, which access specifier modifier we can apply on variable, on constructor and on method. That we will see in this portion. Followed by, after seeing the syntaxes of all the 4, class, variable, constructor and method, we will see the consequences. After specifying each access specifier and access modifier on class, variable, constructor and method, what happens? The consequence we will discuss in the next topic. So coming to the syntaxes of declaring class, variable, constructor, method, the first one is class. To class, you tell me how many access specifiers we can apply on class. On class, we cannot apply private. Class member can be declared as private. Class should not be declared as private. There is no meaning in declaring class as private. Class member can be private. Class should not be private. Second, if you don't declare class as public, like simply if you write hello class, class hello, it is not having any prefix like public or anything. So by default, it is a default access specifier, and a class can be declared with a default access specifier. Third, class cannot be declared as protected because class members can be declared as protected, but class should not be declared as protected. So then finally, class can be declared as public. See, one thing. If class want to be useful only within the package, then you declare class as default. They don't write anything, just write class and followed by class name. Don't put any prefix. So that by default becomes a default access specifier. So if class want to be used only within the directory, we don't want to use the class outside the directory. So so-called package, whatever it is. So if you don't want, then you can go for default access specifier class. If class want to be accessible within and outside the package also, throughout the system, if the class want to be accessible, then class should be declared as public, class. If at all, if you declare class as public, along with public, package declaration also should be there. And a package declaration without public or public class without package declaration has no use. And both must be applied. Class must be public and package also should be declared. Then only class can be accessible outside the directory structure and then outside the package. So class can be default or public but cannot be private or protected. Right. Whereas coming to the variable, constructor and method. To variable, constructor and method we can declare private. To variable, constructor and method we can declare default. To variable to variable, constructor and method we can declare protected. To variable, constructor and method we can declare public. But remember, to the class, I'm sorry, this is wrong. To class only default and protected. We cannot apply protected, we cannot apply private. To variable, constructor and method we can apply all the access specifiers. I'm sorry, this is wrong. It should not be. Variable, constructor and method protected. Coming to the modifiers. How many modifiers are there? Abstract, final, static, transient, volatile, native, synchronous. 7 access modifiers. Out of 7 access modifiers, transient and volatile will be applied only on variables. Take them out. So 5 remaining. Synchronized and native can be applied only on methods. So remove them also. So out of 5, 2 will be detected and 3. The 3 remaining are abstract, final and static. A class can be declared as abstract. A class can be declared as final. A class cannot be declared as static. Transient, volatile, native, synchronized are out of discussion right now. So class can be abstract, class can be final, but class cannot be static. Same thing I have written here. Class can be abstract, class can be final, class cannot be static. And then abstract, to what else we can apply is next to the class, abstract can be applied in method. Only if method becomes abstract, then class will be declared as abstract. And if any class contains abstract method, such classes becomes abstract. There is no intention of declaring class as abstract as such. If method is unimplemented, if method is declared alone, if method is abstract, if the method is having only declaration but not implementation, then such methods are declared as abstract. A class which contains such abstract method becomes an abstract class. So class and method can be abstract. Coming to the final. A class can be final, a variable can be final, a method can be final. Constructors are completely exempted from the access modifiers. We cannot apply any access modifier on constructor. On constructor, we can apply only access specifiers. We cannot apply any modifiers. So, final can be applied on class variable method. The next, static. Static can be applied on variable, static can be applied on method, but static cannot be applied on class. Constructors out of discussion, variable and method. Only to variable and method. These are small mistakes I didn't observe it. Variable and method. So static can be applied only on variable and method, but not to the class. Final, class variable method. Abstract, class and method. Transient, only on variable. Volatile, only on variable. Native, only on method. Synchronized, only on method. These are what? The access specifiers and modifiers we can apply on class variable and constructor. In the consequences topic, by applying these access specifiers and modifiers on class variable constructor method, what happens will be discussed in the next coming topic, in the consequences session. But this session is dedicated only to understand the syntax of declaring these four class variable and constructor method. Only syntaxes. The same thing. Class can be default public, class can be abstract final. This box is only dedicated for class. Coming to the variable we can apply all private, default, protected. Modifiers to variable, final, static, transient, volatile only for variables. Abstract cannot be applied. Native, synchronized are on the methods. So the next coming to the constructor. To the constructor we can apply all access specifiers, private, default, protected, public. But no modifiers can be applied on constructor. Coming to the method. To method we can apply all access specifiers, private, default, protected, public. Coming to the access modifiers. A method can be abstract, a method can be final, a method can be static, a method can be native, a method can be synchronized. Method cannot be transient and volatile. Method can be abstract. If method is not having any implementation, methods which are not having implementation are declared as abstract. Unimplemented methods. Okay, coming to the final, opposite to the abstract. Final, method is implemented, it should not be rewritten or overwritten in the subclass. Abstract method must be implemented in subclass. Final method cannot be overwritten in subclass. So these two are quite opposite, abstract and final. Method can be applied both. And methods can be declared static also. And there are some consequences comes where you need to declare the methods as static also. And native and synchronized will be covered in the multi-threading topic, synchronized methods. And native we are not covering because to the native, the methods, the Java methods whose implementations are written in any native language, something like C, C++. In such cases, we will declare methods as native. Mostly the device driver programming people will mostly implement native methods. So as application developer, we don't use native method implementations much. Those who want system interactions, they will implement native methods. Coming to the class syntax. How to declare class? How many parts a class declaration contains? Coming to the class. A class can be declared with access specifier first. Access modifier next. Okay. The next class keyword. Okay. Then class name. Okay. Class name. Okay. The next, from which class the class is extended from, Okay, superclass, only one superclass, because Java supports only multi-level inheritance but not multiple inheritance. In Java, a Java class can extend from only one superclass. You cannot implement from multiple superclasses. It's not like it's not like C++. Okay, extends from only one superclass. And there is a special type of class introduced in Java called interface, which is a pure abstract. Similar to class but not a class. So it's a pure abstract class given as a named as interface. So we'll discuss interfaces later on. A class can implement from any number of super interfaces. There is no maximum limit for the number of super interfaces. A class can implement from even 5 to 10 super interfaces also. From the super interfaces, what class will get is only the method declaration but not implementation. Implementation should be written in this class only. But implemented methods will only come from one superclass. That's why Java supports multi-level inheritance. It will get method implementations from only one superclass. Only method declarations or method definitions will come from multiple interfaces. Those implementations are provided in this class. Hence, it's not fully partial, and it's not fully multiple inheritance. It's a partial multiple inheritance, extending from one class, implementing from multiple interfaces. And this is the 6th point. So, a class declaration syntax is divided into 6 parts: access specifier, access modifier, class keyword, class name, extend superclass, implement super interfaces. Flower based open and close. Inside that, we iterate the class body. Inside class body, what we'll write? We'll declare variables, we'll implement constructors, we'll implement methods. That's all. A class can extend from only one superclass. A class can implement from any number of super. And here I mentioned few small examples on class declaration. Class A, see, there is no access specifier prefix to the class keyword. And this is a default access specifier class. This is class A. This is abstract class A, and the access modifier is applied. This is abstract class. That means the class is not fully implemented, partially implemented. Might be this class contains some abstract methods. Okay, such classes are declared as abstract class. So access modifier class name. And one more important point: out of these 6, access specifiers are mandatory to prefix to the class, optional. Which are kept in the angular bracket are all optional. Is access modifiers are mandatory or optional on class? Optional. Because that's why we declare simply class A. Only class name and class keyword and class name, only 2 are mandatory. Access specifiers are optional. Access modifiers are optional. Extending from superclass is optional. Implementing from super interface is optional. This class name is sufficient to write a normal class. Okay. And coming to the class declaration is completed. The next coming to the abstract class A, that is completed. Public final class A extends ABC, implements XYZ, and public access specifier. Final access modifier. And this final class can be only instantiated and used but cannot be inherited. In the consequences session, you'll see that. Access specifier public, final access modifier, class keyword, class name, extends from one superclass, implements from multiple super interfaces. Under the example, this is above syntax is exactly implemented here. And the next, this is public class. Without public class also, we declare class hello, extends hi, implements A, B, C. And this is default access specifier class. This is public access specifier class. So as I told you, to this public declaration class, package declaration also should be accompanied. Then only the class can be accessed outside the package. This is class declaration, syntax, and followed by examples. Coming to the variable syntaxes. In this topic, once again, I am reminding you, we will discuss only syntaxes but not the consequences. What happens if you declare so-and-so access specifier? What happens if you apply so-and-so access modifier? That we don't discuss in this class. This class is dedicated only for the syntaxes of declaring these 4: class, variable, constructor, method. So variable also, first access specifier comes, which is optional. Access modifier comes, that is also optional. To variable declaration, data type is compulsory, variable name is compulsory. Data type and variable name are compulsory to declare variables. Access specifiers are optional. Access modifiers are optional. Variable name, another name for the variable name is identifier. Data type, variable name, only these 2 are compulsory. including initialization is equal to assigning some value. Initializer or value or literal, whatever it is, that is also optional. And to the variable only data type and variable name is compulsory. Value initialization, variable initialization is optional, access specifier is optional, access modifier is optional. Here are a few examples of a variable declaration. Private int I. So it's a private variable. It is having only access specifier, no modifier, just data type and variable name. Int I. What next? The next coming one is integer. There is no access specifier, no access modifier, only data type, variable name, no initialization. The next protected access specifier, int, data type k, variable name is equal to 10, initialization. So except modifier, all access specifier, data type, variable name, access modifier, access specifier, protected only access specifier, data type, variable name is equal to value. Public final int L is equal to 10, access specifier, access modifier, data type, variable name is equal to value. So we applied access specifier, we applied access modifier, data type, variable name and initialization. All are declared here. It's a final variable. And at the time of declaration only the final variable value should be initialized. After initialization, after declaration and initialization, we cannot reinitialize variable, final variable. That we'll see later. Public static final int m is equal to 10. One access specifier, two access modifiers. Generally, to class variable constructed method, only one access specifier, one modifier can be applied. But here we applied two modifiers. In Java, not only in Java, in every object-oriented programming language, it's common. In most of the object-oriented programming languages, a final can be combined with static. Not static will be combined with final. Final will be combined with static, not static final. Final variables which are final are recommended to be declared as static. So to consume less space, because static variables will have a static memory, not a dynamic memory, not in the instance memory, in the class memory. That is why they should be declared as static also. Anyway, we'll discuss it again. So public static access specifier, two access modifiers, data type, variable name is equal to initialization. The next comes transient int n is equal to 10. It is a modifier, data type, variable name, value. Volatile int o is equal to 10. Modifier, data type, variable name, value. Coming to the constructor. Coming to the constructor also, to the constructor only access specifiers we can apply, we cannot apply access modifier. That will be very clear. No modifiers we can apply. No abstract, no final, no static, no transient, no volatile, no native, no synchronous. Only private, default, protected, public. Any one of the access specifier can be applied on constructor. Next, constructors are named not optionally. It is mandatory to name constructor name same as class name. Suppose if you write class hello, hello class must contain constructor with the same name hello. Suppose if class name is employee, employee class must have employee constructor. Student class constructor with student. Like that. Class name and constructor name both should be same. And constructor don't contains return type because its default return type is class type itself. And hello class constructor return type is hello itself. Employee class return type is employee itself. It's not void. Because we are not mentioning any return type to the constructor, we don't assume that there is no return type. We should not mention return type to the constructor, but don't say constructors are not having a return type. Same class type is the return type of the constructor. So we don't specify. Hello. Mentioning two times doesn't look nice, right? Okay. So only access specifiers we can apply in constructor. We cannot apply any access modifier. Class name we should write as a constructor name. And in the constructor, we can pass 0 parameter, 1 parameter, 2 parameter, n number of parameters. There is no maximum limit for the number of parameters. The only maximum limit is in the class constructor. Suppose if somebody asks how many parameters you can pass in a constructor, we can say one thing. We should say one thing that as many number of variables exist in the class, as many number of class variables want to be initialized in the constructor, those many variables we should pass as a parameters in the constructor. That is the only thumb rule. So the number of parameters in the constructor depends on the number of class variables we want to initialize. Maybe there may be 100 variables exist in the class, but as many number of variables in the class, want to be initialized in the constructor, only those many number of parameters should be passed. And it all depends on number of variables of the class. So while writing the constructor, we should write parameter type first, the next parameter name next, then parameter type next, parameter name next, and so on. Parameter type, name, and so on. And after that, close a flower bracket. Inside the flower bracket, you declare all the initials, all the class instance variables. And then you assign these values to class instance variables. Suppose if employee class is having employee, you assign this employee to class instance variable employee. Sorry. Employee name is equal to employee name. And if class instance variable names and constructor parameter names, if both are same, they can be differentiated with this. All this prefix refer to class instance variables. This EADE name refers to constructor parameters. So class variables are initialized in the class constructor. How? By constructor receiving the parameters from client, it will initialize class instance variables. That instance. Example, private employee, private access specifier constructor with no parameters. Employee class constructor with no parameters. Employee class constructor with int parameter, int employee. Employee class protected constructor with two parameters, employee and employee name, two parameters. While writing, while writing the constructor, we should call them as parameters. While calling the constructor, whatever values we pass, we should call them as arguments. These are parameters and these are the arguments. Passing time are arguments. Return time are parameters. And there is one public employee class constructor with how many parameters? 1, 2, 3, 4. Employee name, salary designation. Public employee class constructor with 4 parameters. Here, protected employee class constructor with 2 parameters. Here, employee class with 1 parameter, int parameter. Here, employee class with no parameter. This is constructor declaration. Coming to the method declaration. Also. In the method also, method contains access specifier first, which is optional. Access modifier next. Public, abstract, access specifier, access modifier. Then next, return type. Return type is compulsory. Access specifier is optional, access modifier is optional. Return type is compulsory. Method name is compulsory. Inside the method, parameter type and parameter name and so on. These are all optional. And next to the method, we will write throws exception. And we don't discuss about these exceptions right now. This will discuss in the exceptions topic. Throws exception. These are optional. And the access specifier is optional. Access modifier is optional. Parameter type and parameter names parameters are optional. Throws exceptions are optional. Only to the method name and its return type. Only these two are mandatory. Only those two are mandatory. And you see, return type and method name are only written outside the angular bracket. Access specifier is kept in the angular bracket. Access modifier is kept in the angular bracket. Parameter type and names are kept in the angular bracket. And those exceptions list are also kept in angular bracket. Angular bracket means they are optional in the syntax. And to the method, only return type and method name is mandatory. Parameters are optional, including void add. Enough. No compiler will give an error. No compiler will give an error because return type is there and method name is written directly. Parenthesis is open and close. Because there are no parameters, at least you should open and close. Because there are no parameters, we should not ignore these parentheses. So just open and close empty parentheses and use a flower basis for the method body. Even you don't write anything, just open and close the flower basis, it will give an assumption that the method is implemented. If you don't implement the method and if you put semicolon, then it will become an abstract method. This is if you put semicolon, then it is abstract method or unimplemented method. This add method is implemented method, but with no implementation, no body inside the method. And the next coming to the abstract method. Public abstract double divide int I, int j. And if you pass I and j will be divided. And the resultant value will be k will be returned to via the method. So method name, method parameters, two integer variables, return type double, and method access specifier and modifier are public abstract. Abstract means the method don't want to be implemented, an unimplemented method. Such unimplemented methods should be end up with semicolon time. Usually the method will write flower bases, will write open close flower bases. That means that is method body. If you don't want to provide a method body, method implementation, and if you want to declare only method, put semicolon at the end. So methods which are end up with semicolon are assumed as abstract methods. They are unimplemented methods. Such methods are called as abstract methods. Opposite to abstract is final. Final methods are implemented, they cannot be rewritten or overridden in subclasses. Public final int add int a comma int b, written a plus b. So divide is a method, add is a method, that is divide. This is add is a method which is taking two int parameters, both it is adding and returning. What is the result of two summing of two integers? Int only. But if you divide two integer variables, the resultant is the resultant is floated double. Division always returns a floating point value, and addition, subtraction, multiplications will always give int. If you add two int, if you subtract two, if you multiply two int only will be the return type. But if you subtract two integer variables, the result is floating point value, floated double. So here I am writing return a plus b. This is a method body with implementation. This is just method body with empty body implementation. This is only just a method declaration. This is abstract method. This is empty method implementation. This is concrete method implementation. This is here method is fully implemented. So here we applied access specifier, access modifier, return type, method name, parameters. But no exceptions are written here. Here it is. So as arithmetic exception. This is how we mention exceptions list. Anyway, exceptions we'll discuss in the later section.
Like, share and subscribe. Hit the bell icon for more updates.